You think you've had a bad day at work? Try being the IT guy for a server that's, oh, I don't know, 140 million miles away. Yeah, that's not a joke, that's a real job.
You know how you get mad, I mean furious, when your ping hits 50 milliseconds? Try 2.4 million milliseconds. That's the latency to Mars. We're not talking about lag spikes here. We're talking about a lag that you measure with a calendar. Okay, let's just walk through this because it's completely insane. You want to run a simple command, right? Just to see what's in a directory. You type it, you hit enter, and then you go make a sandwich. You could probably watch an entire sitcom episode. Why? Because it takes 20 minutes, 20, for that signal to even reach Mars. Then the rover runs it, and it's another 20 minutes for the result to come back. That's 40 minutes. For one command. 40. This is my name. So, dealing with that kind of lag, you must be thinking, well, at least the hardware is top of the line, right? I mean, for billions of dollars, it's got to be some kind of alien supercomputer. You would be so wrong. I mean, come on. It's a nuclear-powered science lab driving around on another planet. It has to be running the best tech we've got. It's obvious, isn't it? Nope, not even close. That $2.7 billion rover, it's running on a PowerPC 750. You know, the one that clocks in at a blazing 233 megahertz? And if you're thinking, that sounds familiar, it's because it is. It's the exact same chip from the 1998 iMac G3, the colorful one. Your watch, the thing on your wrist right now, is an absolute beast compared to this thing. So, why? Why on earth would you put a museum piece in a spaceship? The reason is pretty simple, actually. Space wants to kill your computer. That's it. Once you leave the cozy little magnetic field of Earth, you're in a shooting gallery, and your electronics are the target. And the main assassins are cosmic rays. These are just these high-energy particles flying through the universe. When one of those little bullets hits a modern super-dense chip, poof, it flips a bit, scrambles data. It's like a tiny little EMP blast to the chip's brain. A brand new CPU just wouldn't last out there. So what's the solution? NASA had to make a choice, speed or survival. And they chose survival. They use these old radiation-hardened chips. The circuits are physically bigger, they're tougher. They're built to get smacked by the universe and just shrug it off. It's not about how fast it can go. It's about making sure it doesn't die. It's a tank, not a race car. Okay, fine. The hardware is basically an antique. So what about the software? They must have some slick, hyper-optimized database, right? Like a stripped-down version of Postgres or something. Oh, please. Don't even. On Mars, if your code is complicated, it's already dead. You think you're going to be running a nice little SQL query, select star from Mars_rocks, where, whatever? You want to join a few tables, run some complex analysis on years of data? Yeah, keep dreaming, buddy. That is pure science fiction. That kind of software is way too bloated, way too complex. It's got a million different places it can break. And what happens if some obscure feature in your fancy database engine has one tiny bug? The rover is toast. Done. The end. The reality? There's no database like you and I think of it. It's just a bunch of super simple custom file systems. We're talking flat files, telemetry logs, image files with timestamps. That's it. They're basically the most over-engineered, indestructible text files you can imagine, and they have one job. When you tell it to save something, it better be there when you come back. And this is where it gets really terrifying. The stakes, the pressure. See, down here, if we screw up, what do? We roll it back. We restore from a backup. No big deal. On Mars, there's no backup. There's no undo button. Not one. Think about it. On Earth, a whole company can accidentally delete its entire cloud setup. It's a disaster, yeah, but you can fix it. It might take weeks, but it's fixable. Now, imagine a NASA engineer pushes one bad update, just one, and it corrupts the rover's flash memory. That's it. It's over. You can't exactly send someone up there with a USB stick to reinstall the operating system, can you? What you've just done is permanently bricked a $2.7 billion machine, a unique scientific instrument on another world. All gone. Because of one typo. No pressure, though, right? This is, and I am not exaggerating, the most high-stakes DevOps job in the history of humanity. So the next time your build fails or your query is running a little slow, just take a deep breath
And think about the people managing a 1998 iMac from 140 million miles away, where a single typo costs billions. All of a sudden, your slow query doesn't seem like such a big deal, does it?